Hey everybody, my name is Aaron Lechuga, and today I'm going to be talking about the sampling methods and mass analyzers and detectors. Let's begin. So again, purpose of this training, like I mentioned just a bit ago, it's going to be discussing how these sampling methods, mass analyzers and detectors basically together in forensic chromatography. Now, in forensic science, which most of us are mastering in right now, these samples are usually limited. They're real complex and they're legally sensitive. So choosing the right combination of tools is extremely important. Now, thus far, I've read that poor instrument pairing can lead to false results or weak courtroom defensibility. Sorry, and from my perspective, that's like one of the biggest risks in forensic analysis. Now, the tools we choose don't just affect the accuracy; they affect justice, public trust, and case outcomes. Sampling techniques used in forensic science. So, before any analysis can happen, the sample has to be properly prepared. I've read that the sample prep is often one of the most critical steps in forensic chromatography because it directly impacts the sensitivity and reliability. Now, the solid phase extraction, or SPE, it's commonly used for biological fluids like blood and urine because it concentrates to analyte and removes interferences. Now, headspace sampling it's pretty ideal for volatile compounds like alcohol, solvents, and fire accelerants, which I think is especially important in fire debris and DUI cases. Liquid extraction is another method used to separate drugs and toxins from aqueous samples. From my perspective, good sampling is what sets like the foundation for accurate and defensible results. Next slide, mass analyzer and quadruple. So the first mass analyzer I'm discussing is the quadruple, which is commonly coupled with both gas chromatography (GC) and liquid chromatography (LC) to form GCMS or LCMS systems. Now, I've learned that these quadruples are one of the most and widely used analyzers in forensic laboratories because they're reliable, they're cost effective, and they're versatile. Now, again, something I mentioned in one of my discussions earlier is the whole cost effective thing, which seems to be kind of like the major point in a lot of these labs. Um, so they work by filtering ions based on their mass to charge ratio, using oscillating electric fields. Now, in practice, headspace sampling is used for volatile samples like fire debris, like I mentioned earlier, while SPE or liquid extraction is used for biological fluids. Now, from my perspective, quadruple systems is like the backbone of forensic analysis because they balance performance with the practicality while still producing courtroom defensible results, which is, of course, our goal. Mass analyzer time of flight. The second mass analyzer is time of flight, or TOF, which is best paired with liquid chromatography. So LCTOF to MS systems. I read that TOF analyzers are known for their high mass accuracy and ability to identify unknown compounds. TOF works by measuring how long ions take to reach the detector, which allows for extremely precise measurements. Now, sample prep usually involves SPE or dilute and shoot methods. Again, from my perspective, TOF is especially valuable when dealing with novel drugs or like unknown substances because it allows these analysts to identify compounds even when there's no reference standard exists. Detector, so flame ionization detector, FID. Now, the flame ionization detector, or FID, is best coupled with gas chromatography, GC. I've learned that FID is highly sensitive to organic compounds and is especially effective for hydrocarbon analysis. Now, it works by detecting ions produced when organic compounds are burned in a flame. Now, these headspace sampling or solvent extraction is commonly used with GCFID analysis. This detector is widely applied in fire debris analysis, ignitable liquid identification, and blood alcohol testing. Um, excuse me, from my perspective, the FID is extremely valuable for like quantitative work because it provides consistent and reliable results, like even with these complex mixtures. Detector UV visible, so UV VIS. Now, the UV visible detector is most commonly paired with liquid chromatography. Excuse me. I read that UV BIS detection is widely used because it's cost effective. Again, one of the major points, and reliable for known compounds that absorb ultraviolet and visible light. Sample prep usually involves SPE and filtration. This combination is commonly used in forensic drug analysis, like pharmaceutical testing, poison identification, and toxicology screening. Now, the UVVIS is also a great screening tool because it allows labs to process like high volumes and samples quickly while still maintaining acceptable accuracy. Excuse me. Effective instrument pairings. So to summarize, GCMS with a quadrupole analyzer is ideal for volatile drugs, fire debris, and explosives. Using headspace sampling, of course. LCMS with a quadrupole is commonly used for drugs and biological fluids using SPE or liquid liquid extraction. LCTOF to MS is basically best for unknown compounds and trace evidence using SPE or dilute and shoot methods. Now, the gas chromatography FID is ideal for hydrocarbons and alcohol analysis, while liquid chromatography UV is commonly used for routine drug screening and like pharmaceutical analysis. Um, from my perspective, having versatile systems that can handle these multiple case types, I should say, is one of the most smartest investments any lab can make. And to conclude, the correct pairing of sampling methods, chromatography, these mass analyzers, and detectors, they ensure accuracy, efficiency, and courtroom defensibility. Now, from what I've learned this far, the backlogs and underfunding are major challenges in forensic science. And from my understanding, choosing the right instrumentation, can help labs do way more with fewer resources. Understanding these combinations not only improve case outcomes, but they also strengthen the public trust in forensic science, which is, of course, at the end of the day, is our goal. Thank you so much.